Hey guys, so this is going to be the last two problems on that review sheet. This one, letter D, is a very interesting problem. So we got to make sure we understand what's happening because it actually combines a lot of different things at once. Okay. Now, as we talked about a class, I'll scroll up a little bit to show it. And for sine and for tangent, so this also works for tangent. When we talk about the inverse, we have to limit the domain from negative root 2 or negative pi over 2 to pi over 2 in degrees, negative 90 degrees to positive 90 degrees. And the reason we have to limit it to that area is because we want to avoid having a double answer. For example, sine of a half, the inverse of sine of a half, could happen at 30 degrees and 150 degrees, which is in the second quadrant. So we want to avoid that. So we need a positive and negative quadrant, and we use that one on the right. So for sine and tangent. Now, in cosine, though, the issue is we have a positive and a positive here. That kind of sucks. So we cannot use from negative 90 degrees to positive 90 degrees because they're both positive, so that doesn't help us. So instead of using that, we're going to use the second quadrant because that's where cosine is negative. So in this case, for cosine, your inverses has to be from 0 degrees to 180 degrees. In terms of radians, 0 to pi. And that's for cosine only. And remember, the reason it is for cosine is because you need a negative and a positive version. So just think of it like that if you double guess yourself. Now, we have cosine of negative 1, 2 over 3. Understandably, you're going to look at that and say, wait a second, Mr. Tobel, there is no x value on the unit circle that is just 2 over 3 or negative 2 over 3. And I'm going to say you're correct. So what we have to do is make a right triangle with a reference angle. Now, my thing is, in this situation, we have negative 2 over 3. If you remember, cosine, and this is why this question is tricky because it involves a lot of things, cosine is x over r. Also, you can remember it as adjacent over hypotenuse. So if I have negative 2 over 3, I know my x value should be 2 to the left. And I'll use red to indicate that, is 2 to the left. And I know my r value, which is typically my hypotenuse, is going to be 3 units. So this is 3, and this is 2. Yeah. If I look at sine, I know sine is usually opposite over hypotenuse, or you could think of it as sine as y over r. Now sine, though, we need a y value in order to do that. Now notice here, I'm not actually getting a numeric value for the degrees. I can't do that by hand, and you're not expected to do it by hand. So we're going to form that right triangle to help visualize this situation. So this one, we have sine, and we need a y, and we need the r. We already have the r, which is 3, so we need that y value. I don't have the y value, but what I can do is a little bit of Pythagorean theorem. So I could do 2 squared plus y squared equals 3 squared. That's going to be 4. That's going to be 9. Y squared equals 5. 9 minus 4 is 5. Square root both sides. Y equals the square root of 5. So y equals the square root of 5. So when I ask, what is the sine of this angle? Which, by the way, it's the same angle as the cosine negative 1, negative 2 over 3. it's going to be y over r. So in this case, your sine is going to be root 5 over 3. So your sine is root 5 over 3. There is a lot of elements here because you're involving this kind of information and you're involving Pythagorean theorem, and we talked about the cosine. So this is a really busy problem. All right. I realize you could just pause the video if you need to copy this, so I'm just going to go on. Next one, secant arcsine 4 over 5. Another way to write that, secant of sine inverse of 4 over 5. Rightfully so, you look at it and say, Mr. Tobel, there's no y value in the unit circle. That is 4 over 5. I would say you're correct. So we're going to kind of do the same thing as the previous problem. I'll keep myself in mind that sine is y over r. Keep in mind secant, which is, remember, the inverse of cosine, would be r over x. And if you don't remember that straight through, just remember, what's secant? Oh, I know secant's the opposite of cosine, and I know cosine's x over r, so secant must be r over x. So there's a thought process of that. Again, it's either you know the base of it and you could find it, or you just remember everything. Same thing to the unit circle. Either remember everything or know how to derive everything. So sine negative 1, 4 over 5. So we have the same situation. Since the sine is in the positive version, oh, my fault. This is going to be this is sine, so it's positive 5 root over 3, but I technically should have been put a negative 2 here the whole time. That's my fault. I'll fix that later. I'm already recording this, so I posted this, but my past self will know that. I'll post it in like the description. Hey, I forgot to put the negative. I remembered it halfway through. Don't sweat it. Okay. Here, we have a right triangle. Now, it's a positive 4 over 5. And if we scroll back up, we know the positives of sines. We'll do that in the first quadrant. We're going to do that in the first quadrant. So a positive 4 over 5. So this is y and this is r. So I know my y value is 4, and I know my r value is 5. I need to figure out what my x value is. So do some Pythagorean theorem. If you remember some of the stuff from geometry, this happens to be a Pythagorean triple. If you do your math, x equals 3. Even if you don't remember it's a triple, you could just do the math, x equals 3. So since my secant is r over x, my r is 5, my x I just found is 3. So the secant for this answer is r is 5 over x of 3. So 5 over 3. Okay. All right, that's done with the recording. I'm going to check if I have posted everything. I'll post this answers too. Otherwise, have a wonderful day, guys. I'll take questions on over the Sunday. Maybe I'll do some recording. I don't know what I'll do. But enjoy it. Have a wonderful day.